Hi everybody, it's Mrs. Peachy from your physical science class. Today we are going to be looking at your portfolio on modeling molecules, which deals specifically with covalent compounds and how to draw the Lewis dot structures for them. I did do a separate tutorial last week and recorded that and put it on my Google site as well, and it also kind of gives you some insight into how to draw Lewis dot structures. But today we're going to look specifically at the ones that are on the lab, and also at the very end of the lab it asks you to look at the actual physical structure of the molecule. What does it look like? What are the bond angles? And that stuff can be a bit complicated as well. So when you do go through this, you will get a link to a PDF, which is right here. And as I remind you all the time, I just want you to remember that you do need to save this first to your computer. So right click, save as, and then save it to your computer wherever you'd like to. However, I would recommend putting it on the desktop, and then from there you can move it to someplace else if you want, but that way it's easy to find. Then close this window and go to your desktop, open it up, and start making changes in there from that point. Then save it again, and you should have a permanent record. If you try to make changes in here without actually doing that, they will not be saved. Okay? So let's look at this. It talks about Lewis dot structures of just specific atoms to begin with. And if you remember, I mentioned to you during one of my last videos that you can figure out how many valence electrons are found in a particular atom just by using your periodic table. So if you don't have a physical periodic table yet, I would highly, highly recommend that you get one. There's many places you can print them out online for pretty much, nothing. And just a cost of like a little bit of ink on your, a little bit of ink and, some paper, I guess. So I'm going to go ahead and make this just a bit bigger so you can see my full screen for the time being. And then we're going to kind of go back and forth between this and the worksheet that you have for this lab. All right, I want you to remember on your periodic table that you should have some numbers at the very top of the screen. And I know I've mentioned to you this before, but oftentimes I have to rewrite these. These are the charges, which we're not really going to use right now. But the other numbers in red here are the number of valence electrons in each of these individual atoms. Valence electrons are important because they tell us whether or not an atom tends to give away its electrons or take electrons. And of course, they're also going to give us some insight into the charge of the ions once that does. Once it does it. With covalent compounds, which is what we're looking at now, remember they're not giving away and taking electrons so much as sharing them between them. So this becomes important in how those electrons become distributed within or among the atoms in the compound. Looking back at the screen here, nitrogen, hydrogen, oxygen, and carbon are the individual atoms that are given to make electron dot diagrams. So those are going to be pretty easy. Go back to the periodic table. I'm sorry, I forgot which ones they were. Go back to the periodic table. We're going to look at nitrogen. Nitrogen has 5 valence electrons in red here. So in order to make my electron dot or Lewis dot structure for nitrogen, I'm just going to put an N, and I'm going to place 5 dots around my N. And that's what I do. So pretty easy. If I go to my screen, I can actually draw in here. I can put again, I didn't save this, so you want to make sure you save it first. But you're going to want to put dots. I enter nitrogen, use a colon, and then another dot. Oh, sorry, there's just 5, my bad. Okay, so that'll give me kind of the look that I want to make that Lewis dot structure. You can use periods to make the horizontal dot side to side and a colon to make the vertical dots. All right, so super easy. You could do hydrogen, oxygen, and carbon next. A little bit more difficult is to draw electron dot diagrams for the molecules. Okay, you're not putting any bonds in here yet. You are just doing dot diagrams. So the molecule for hydrogen, the first one, is not hydrogen, the element, just H. It's H2. I'm going to go ahead and give you my notebook again. So H2, hydrogen, is a diatomic molecule. So that means there are two hydrogens that are bonded together, and that forms gaseous hydrogen. That's going to be the stuff you can find, you know, a lot of times they can use it as a power source, actually. So when I look at the periodic table, hydrogen has one valence electron. So my molecule, hydrogen, is going to look like this. Two hydrogens, each with one valence electron, and they share those. So they're going to be between the hydrogens. Okay? So they're between them. Whenever you've got, and actually this might even be better illustrated like this, but whenever you see two hydrogens, or any molecules, or excuse me, two of any atoms with two dots between them, that indicates a single bond. So I can actually draw this like connecting the dots, making a single bond. And if I go to the next part of the activity, it's going to have you do that. Make the single bond here. If there's four dots between them, if I had four dots here, that would be what's called a double bond. So an example would be, let's say, well, let's just do let me think here for a second. Well, we can go ahead and just do oxygen since that's the next one up here. Oxygen is O2. Okay. Oxygen each has 6 valence electrons around them, and they need to have a total of 8 to be stable, remember? Hydrogen's the exception because it only has one shell. So to get the 8, you need to have 8 around each of the oxygen atoms. So oxygen, there's only 2 atoms. We have 12 total, right? 6 on each. So we need to divide this up so they each have 8. 8 plus 8, 16, so that doesn't really make a lot of sense. You can't just evenly distribute them around there. So they're going to have to share more than one pair. So I'm going to have them start off by sharing 2 pairs. Okay, so that's 4. Now each oxygen atom has 4. That gives me 8 more. Well, if they each have 4 and there's 8 left, I can divide that equally and give them each 4 more. 4 and 4 is 8. So theirs look like this. You see how they now each have 8? This oxygen atom has these 8. And this oxygen atom has these 8. And they're sharing those 4 in the middle. So even though there's not enough electrons to go around, they can share them. Because there's 4 that are shared, that makes this a double bond. So when I draw the structure, I will draw it like that, with a double bond between them. Okay, I can actually also put dots up here to indicate that those are unbonded or non-bonding pairs of electrons, which does make a difference later on when we look at other things. When you're using your computer to draw this double bond, you can use the equals sign. That works out really well, actually. So let's look and see how that would look. So the structural formula for oxygen would be, I can do the dots, O, oh, sugar, here we go, O. And then if I use my equal sign, oops, okay, so I can do something like that, and that'll be, just fine. Or if you want to print this thing out, guys, you can do that, and then you can actually just scan it and send it in that way. That works too. Now, when we're moving on here, you're going to do carbon dioxide, and you're going to follow this and do these space-filling molecule or models of hydrogen and carbon dioxide. So these are going to be a little bit different. Okay, so a space-filling molecule will look a lot like what's on here. You can see here at the top is our Lewis dot structure. And then these are two examples of space-filling molecules. So you can kind of draw either one. This one obviously would be better drawn than it would be using any sort of computer image, okay? But if you can figure out how to do it, you certainly could actually look up the space-filling molecule using a Google image and then just insert an image into that box on the PDF. That would work just as well, okay? And there's no reason why you can't do that because these are essentially just drawings of the molecules, what they might look like if you could see them. And thinking about it, not just where the molecules are, but also the bond angle that those molecules make. Speaking of which, I want to go back to the worksheet because the last part of this is actually going to ask you about bond angle. And it says, what is the bond angle between the hydrogen atoms in ammonia, NH3? How about between the oxygen atoms in carbon dioxide molecule? What is the molecular geometry of methane? These questions are kind of crazy because it's not something that's discussed explicitly in your text, and it can be kind of difficult to do. One of the methods that sometimes works is imagining that around any kind of atom, you've got a sphere around it, right? And if you look at a molecule, let's say like, I don't know, say silicon dioxide. Okay, if you look at a molecule like silicon dioxide, that if you take this circle and you realize that there are two bonded atoms, that you take 360 degrees of the circle and divide it by 2, and that tells you that this angle should be 180 degrees. But that doesn't always work because it depends on how those electrons are distributed. And some molecules, like water, for example, have the electrons unevenly distributed, and that leads to slightly different bond angles. So what I'm going to recommend is I'm going to recommend you going to a website. And here's an example of one that you can use. This one is www.avogadro.co.uk/structure/molshape/shapes.html. And what you're going to notice here is that it has a whole bunch of different examples of molecules, and it tells you not only their actual shape, but it also tells you their bond angle over on the right. Okay, so that's what I'm going to have you use to find not only the bond angles, but also the shapes, because one of the questions does ask you about that. Okay, so that should be all that you need to know for the Modeling Molecules portfolio. If you want to go through more examples on how to do covalent bonding and to look at those Lewis dot structures, I do have a supplemental video on my website. If not, good luck with the portfolio, and you can reach me extension 2204.